Suppose Smiths plc have A stores and B warehouses in London valued at Z1 and C stores and D warehouses in Dubai valued at Z2. What is the valuation of a store and a warehouse? We don't know. Let's assume that a store is valued at X euros and a warehouse is valued at Y euros. Then the number of stores and warehouses multiplied by their valuation gives us the total valuation of the asset. Now, we can split this matrix into a system of simultaneous equations. A stores multiplied by the valuation of a store plus B warehouses multiplied by Y, which is the valuation of a warehouse, will give us the valuation of the assets in London, while C stores multiplied by the valuation of a store plus D warehouses multiplied by the valuation of a warehouse gives us the total valuation of warehouses in Dubai. Now, to find the valuation of a store and a warehouse, we have to solve this system of equations simultaneously. Now, solving by substitution, let's make Y the subject of the formula in equation 2 and substitute in equation 1. We have that Y is Z2 minus Cx all over D, and we call this equation 3. If you don't understand how come about this, if you don't understand how I made Y the subject of equation 2, you can please watch my video on change of subject of formula on this channel. Now, if we substitute this in equation 1, we get Ax plus B. In place of Y, we substitute Z2 minus Cx all over D equals Z1. Now, if we open the bracket, we will get, first thing, we multiply all through by the denominator. We get A dx plus B z2 minus C bx will give us D z1. So what we did, we multiplied all through by the denominator and expand the bracket. So this x is the variable we are looking for here. So this will give us A dx minus C bx. Every other thing goes to the other side. D z1 minus B z2. And if we factorize the left hand side, we get AD minus CB multiplied by x give us DZ1 minus BZ2. So if to find x, we divide both sides by what is multiplying x, so that x will give us DZ1 minus BZ2 all over AD minus CB. This is just normally solving simultaneous equations using unknown numbers. In my video on simultaneous linear equations, we use known numbers, that's concrete entities. Now we are using abstract unknown numbers, just imaginated numbers, but the process is all the same. So similarly, if we make x the subject of equation 1 and substitute in equation 2, now we have found the value of x. We want to find the value of y, and we will do that by the same method of substitution. So if we make x the subject of equation 1, we will have x is equal to, firstly, our equation 1 is ax. Okay, let me bring it back. That's the beauty of the sliding board. Our equation 1 is ax plus by equal to 0. We want to make x the subject of this equation. What we do, we take whatever is attached to x here to the other side. So if we take by to this side, we get z1 minus by. Then we divide by a, we get z1 minus by all over a. So x is z1 minus by all over a. We call this equation 4. Now if we substitute it in equation 2, equation 2 is cx plus dy equal to z2. So we will have c in place of x, z1 minus by all over a plus dy equal to z2. Now, if we expand this bracket and multiply each time by the denominator a, we will have c z1 minus bcy plus a dy equal to a z2. Now, if we are interested only in y, we need y. So we are taking everything that is not y to the other side. That will give us a dy minus bcy, a dy minus bcy is equal to a z2 minus c z1. So we take this one to this side and we are left on this side, and we took a dy first because it is positive. That will be easier for us to deal with. Now we can factorize the left hand side, and that gives us ad out, bc multiplied by y is equal to az2 minus cz1. Now to find y, we divide both sides by this, so that y gives us az2 minus cz1 all over ad minus bc. So if we know the number of stores, if we know the number that a represents, the number that c represents, the number that b represents, and d, z1, z2, we can evaluate y. Now in both cases, for x and y, the actual value of x depends on the denominator, ad minus bc. In both cases, they have the same denominator. So that denominator is going to decide the fate of x and y. And for fractions, we know that when the denominator is 0, the fraction is undefined. So when ad minus bc is equal to 0, then this fraction has no definite value. It will only have a definite value if ad minus bc gives us a non-zero value. Hence, ad minus bc is defined as the determinant of this coefficient matrix. So AD minus CB is defined as the determinant of this matrix. This is often denoted with line brackets. So A, B, C, D is equal to AD minus BC. This is the determinant of a matrix.
If you like this video, please subscribe to my channel and turn on notifications for more videos like this. You may as well visit my website www.everydaymaths360.com for more lessons, learning materials, and prep packs comprising over 1,000 thoroughly explained solved practice problems. Thank you.